not have to show everything. Just like when you think back about, like I said earlier, about the congruency statements, when you had to show that you had triangles that are congruent, you had to show that every single bit and piece was congruent, all the corresponding to make it work. And then when we started talking about similarity, it was the same thing. It was the same basic idea. You had to show that all the angles were the same, all the ratios worked out. As you get further along, you don't need to show as much. You don't have to have as much information to say that things are going to be similar. This is where this comes in. Just like if you go back and start thinking about when we started out this unit, first thing we did was this. Cross multiplied and solve. Then we did this. After you did that, you filled in the blanks, cross multiplied and solved. Then you went to this. Which meant that you wrote out this, which then you went to this, then you cross multiplied and solved. Now you will be starting with this, where you'll have and when it says prove, first hour freaked out right away, thinking, oh my God, I gotta do a proof. There's no proof in this. There's no two-column proof. What it's saying is that a way to show that you have things that are similar is by just having two angles right here. Can we please stay off our phones? It would be great. Thanks. Call me crazy, but paying attention, writing stuff down might help you pass classes. So in a triangle, if two angles are congruent, or I should say two corresponding angles, then the two triangles are similar. That's all it is. Which means all you have to do is show you have two angles that are congruent. If you have two angles that are congruent, then all of a sudden everything else falls into place, which means that you can say all your statements, which means then you can do all of your cross multiplying and solving. That's it. It all boils out of that. So like I said, it's just a matter of now being able to look at a diagram, come up with the angles that match up, write your similarity statement, and go. Okay. So for example, can I go? I don't want to get too far ahead of you here. It's rare that I get the acknowledgement from you guys, so I appreciate that. I have these two triangles. Is there going to be enough information here to show that things are going to be similar? Now, bear in mind, at some point in time in this example, what we need to do is be able to figure out what angles themselves could be congruent to each other. But we also have to figure out what the missing angles are equal to. So basically it boils out to being how many degrees are in a triangle? How many? 180. Okay. So we know that we have 180 degrees in the triangle. What do those two little red boxes mean? What do you know about all 90-degree angles? Okay. So I've got one set of congruent angles already. I got to find those missing, that third angle, if you will. Well, take 180 degrees, take out the 90, what are you left with? What's left here then if you take 64? Convenient, isn't it? If you take out 26, what are you left with? 64. So what happens then is that once you get two angles that are the same, what do you know about the third angle? It has to be. We talked briefly about that back in chapter 4, I believe, when we looked at how triangles work with the angle. I think when we did it with like angle, angle, side, or angle, side, angle. It basically is getting, once you have two angles that are the same, the third ones have to be the same because of the triangle sum stuff. It's not that you have to prove it or anything out, but that's how it works. So what you can do now is say that you've got two triangles that are similar to each other. Just pick a letter and work your way through it. Oops. What has to be in the corresponding letters? That's all it is. Pick your letters and go. Now you're able to go from that and finish it out. Okay? So like I said, all this stuff is just adding one step on top of what we've already done. And this one step is pretty darn simple. Okay? Because now you can write out that similarity statement. You could write out all the different parts. You know what has to correspond. CD is to KG, DE, and so on and so on. Okay? But it starts with writing out those angle measures. Okay? Not too bad. Here's where it gets interesting. Having to draw pictures. And this does show up pretty regularly. Excuse me. So a flagpole casts a shadow that's 50 feet long. At the same time, a woman standing nearby, who's 5'4", has a shadow 40 inches long. I'll toss the flag. Now, this is a very common style problem for geometry in terms of similar figures, because it's very visual and it's very easy to draw. First thing you gotta think about is, well, if you have a shadow, what's probably up in the sky? That's usually helpful. I mean, you can get a moonlight shadow, but it doesn't normally happen. So we have this
shadow.
Oh, what?
It's still a sunlight shadow.
Oh yeah, good. I didn't think about it. So we put the sun up in the sky. Sure.
That looks like a flower.
Well, that's actually the flower.
A flower's bigger than the sun?
Not drawn to scale. Okay. So you have the sun. If the sun is up there, where are flagpoles usually installed?
In the ground?
In the ground. Very good. Normally, the ground and the flagpole create what kind of an angle?
90-degree
A
angle.
90-degree angle. That's helpful if you want things to stand up straight.
Unless you're like San Francisco.
Well, even if it's in San Francisco, the hills, the roads are hilly and all that, your flagpole should still be vertical. So even though your hill could be on a tilt, if your hill's on a tilt, you'd still want your flagpole to be vertical to the horizon.
Wouldn't it be 90 degrees?
It's 90 degrees to the horizon,
Oh, okay.
but I see where you're arguing it, yeah.
Okay, I didn't know this.
Because if you're on a hill and you have your flagpole this way, you don't want your flagpole out like that. Your flagpole is going to be vertical to it's always vertical to the horizon. All right, anyway, so go back to, hello. Here's our ground. Here's our flagpole. It's got a right angle. Here's our flag. Now the sun's rays cast the shadow of the flagpole at 50 feet. You guys all, when you do tick marks for feet and inches, one tick marks is feet, two tick marks is inches. You guys know that, right?
Mm-hmm.
So the lady is standing somewhere nearby, and she's 5'4". So
Can I draw hair?
she could have short hair.
Go get it.
All right, I know. We'll put a flower in her hair.
Thank you.
not drawn to scale. It's a big poofy hat. She's going to the
Church.
No, the horse races.
the horse race. What is it?
I don't know what it's
Kentucky Derby. Thank you.
Yeah.
She's going to the Kentucky Derby. She's got her giant flower bonnet on. This is where, come on, this is where you can kind of have a little bit of fun with this. She stands 5'4". Her shadow is 40 inches. Again, not drawn to scale. So what happens here is that we have a bunch of different properties going on as far as how you can, bless you, third time's a charm? Okay. Is how we can say whether or not these things are going to be creating similar figures. What I want you guys to think about here is that this diagram is basically this picture. Oop, that's wrong. This one. It's basically this flipped. Okay. Now, we have a right angle here, and this person is standing here with a right angle. We okay with that? Where is this second angle that's going to be able to show that these guys are shared to get similar figures? Look at what you have. You have a small triangle here, and a large triangle there. What do they have in common? They have the right angles. What else do they have in common? Don't they have that in common? Now, this was something that we didn't do a whole lot of when we did, what do you call it? Congruent triangles. We didn't really have very often a reflexive angle, a shared angle. But in similar triangles, you get that a lot. They share that same angle, that point angle there where it hits, where the sun's ray hits the ground. They both have that same angle. Eventually, we're going to talk about what that angle is called. It's second semester, we call that an angle of elevation. When you're looking off the horizon, looking up at an object, the angle off the horizon up is the angle of elevation. It's a very common thing you use to measure distances. Have you guys ever seen, I'm sure you've all seen it, you ever see the guys on the side of the road with the staff and they're measuring through things out? They're using angles of elevation to what's called surveying, to measure out distances to within minuscule amounts by bouncing lasers off. It's kind of the same idea how rangefinders work, how a golf rangefinder or a target rangefinder if you're hunting and whatnot. It's the same basic principle. It's using a whole bunch of calculations with trigonometry to do this. Our method's a little bit cruder by just knowing certain heights. So they have this here. Also, since these guys are both perpendicular to the same line, that means they have to be parallel to one another. If things are vertical to the same line, remember how we did that? Perpendicular lines, if you're perpendicular to the same line, you're parallel to one another. That also creates then corresponding angles here and here. So you get this idea that when you have two different objects being shared by a sun's ray to cast shadows, that's how they create similar triangles without technically drawing out triangles. It takes a little bit of time to get used to how that drawing works, but that's how that sets itself up. Okay? So now if you think about it, go back, we have height to shadow, height to shadow. 5'4" to shadow is height to shadow. But the trick is, notice that we're in two different units of measure. We have feet, we have inches, and we have feet and inches. What is the easiest one to do? Convert up or convert down? Down. It's always easier to convert down. Convert to the smaller. How many feet are in an inch? We have 12 feet in an inch. So 5 feet is how many inches? 60. So you have 60 for the 5 feet plus the 4 inches gives you how much? 64. So we get the ratio of 64 is to 40 as x is to, well, 50 feet. Multiply that by 12, what do you get?
600.
Excuse me. There's your 600 inches. Now, do I need to simplify that first ratio? No, you got a calculator. Cross multiply and solve. That'll give you your answer in inches. What is that? That is 960 inches. The question, though, asked you to have it in what unit of measure? Feet. So how do I convert that then? You just divide that by 4. Is it 80? Yeah. It's 80 feet. That's a really, really tall flagpole. Okay, it's a really tall flagpole. The height of our school, 2-story building, you think about it, every story is usually, they call it about 10 feet. It's usually about 11 to 12 because of all the plumbing and all the other stuff they have between the floors and stuff. Our school might be 22 feet tall, 23 feet tall. Yes, sir?
In the basement.
Yeah.
Can we go?
The basement is actually, all right, it's not like in the entire building, but if you're ever in the auditorium, in where the pit area is, where the orchestra, that's technically a basement because it goes below grade. So then you have some dressers and stuff like that, I think, believe down there. Yes, sir.
No, the dressing rooms are upstairs, but you go down into the pit and there's like another door that goes lower.
Yeah, and there's some electrical and all that
It's
kind of
crazy.
There's no, it's not like, it's your basement, your house, or anything. It's not anything like that. This is more more of like a foundational thing. They might run the water line thing, internal water coming in and stuff, but it's nothing. Electrical, yeah, the electrical. But that's about all there is. It's not like a sump pump or a bathroom. Yeah, it's not where you're storing all your Christmas stuff.
Yeah.
So, guys. So guys, when you start to think about visually, an 80-foot tall flagpole, that's really, really tall, okay? Think about how tall the student center is. I remember looking this up last year. If you look at how tall the student center is, I want to say it's like 100 feet. I believe that's right. Let's see here. I want to see how. Shh. So it says that it is. It says 17 stories, but how tall is that? All right. So the student center is about 207 feet tall. So you start thinking about it. This flagpole would just be almost halfway as tall as the student center. Flagpoles generally aren't 80 feet tall. That's kind of silly.
How tall is our flagpole?
What's that?
Big tall building with the red dots. The one that we went. It's a Husky, right?
Oh
Yeah.
yeah.
Oh, was that
Oh.
where like the dot is? Bro, is that not what she just?
You guys live in Cal, didn't know that's called the student center?
No.
Where's that not you?
Okay, yeah.
No information united. So basically, what I'm getting at here, guys, is that when you have this type of setup, it's being able to draw the picture, fill in the blanks with information that you have, and try to cross multiply and solve the problem.
Yeah.
Excuse me. Oh, wait, sir. dying slowly. Who owns their stuff?
Mr. Matson.
Merry Christmas.
Don't let us spoil your dinner.
You know how hard it is to miss a day of school?
It's pretty easy.
Yeah, because I have so many classes to go.
Oh, I'm trying. You know what? I appreciate that. I mean, honestly, I feel so much better today than I did yesterday. It's draining away, so it's almost gone. Yes, sir.
It's a good. Are you like congested?
Yes.
In, like the head?
Yes.
area? Great tip. Drink some hot sauce.
No.
Have jalapeno Cheetos.
I know. I know they say. I know they type clears your senses. I know that. It's.
Hot water and honey.
You're not a spicy guy. You should have my dad's soup. It's really good.
I don't mind it. It's just there's nothing but rest and water. It's just one of those things. You know. Sorry. I think I only had one other example here to show you guys, and then just kind of go for it. So, last little example here, and then I'll give you guys some problems to work through. I want to show that these two triangles, there's two triangles that are similar here, and I want to write out a similarity statement. And what I mean by that is I just want to say, triangle ABC is similar to XYZ or whatever the letters might be. But, guys, come on. But what happens here is that you'll notice is that you have to deal again with parallel lines. And when you have parallel lines, it means you have transversals. And when you have parallel lines and transversals, you have angle pair relationships. So you have to remember what ones set up to match up with one another. When we're working with them in terms of triangles, it's actually much easier than it is when you're trying to work with them in terms of just parallel lines within space. Because you're forced to be within a certain side of a transversal. You're forced to be on either the inside or the outside of the lines because it's an enclosed shape. Okay. Now, if you look at it, you've got your parallel lines at CE and BD. Well, that angle has to match up to this one because if you look at it, they're on the same side in the same position. They're corresponding. Okay? Because if you extend this out, that's how that works. It's just a matter of twisting it around, looking at it a little bit different from a different perspective. Same deal with that angle A. See how that angle A is shared between both the small and the large triangle? You see that a lot with similar figures. It's a very fast way to show. How many angles do you have to show that the triangles are similar? Two. Do I have two of them now?
Yeah.
Yep.
Could I have gone and used the other ones at E and ADB? I could have gotten this one and this one as well. So when you write out your similarity statement, it's just a matter of picking one of the tick mark of the angles and making sure it matches. If I say triangle BAD, what does the other one have to match up to be? That's it. Okay. And then from there, you'll be able to write out if there's missing side lengths, set up the proportions, and go. Okay? Not too terrible? At least it's on the lower echelon of terribleness.
Yeah.
Let's see.
50 to 500 even.
What I have you guys working on tonight, I'm giving you a couple minutes to start up. So this is what, 6.4 in the book. believe it's 3 through 12, 3 through, and okay. If you give me a sec, I will pull some of this up so you guys can get started on it because you have a little bit of time. Whoa, 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 whoa! Shh. I'm pulling this up so you guys can have a couple minutes to start on it. Yes, ma'am. What's that? Miserable. I was sick. Well, bless you. What was the worst was when my throat was really sore and I was sneezing. It hurt. That was awful. That was Saturday and Sunday. Yes, ma'am.
I get to dress really often, and last night I choked on pretty much Reese's, and it's cold, and so it scratched the inside of my